What if I told you that gravity, the force that keeps your feet firmly planted on the ground, might not just be a simple attraction between masses? What if instead it's a complex interplay within the very fabric of space and time? Welcome to What If It's All a Game. Today, we dive into the intriguing question, what is gravity? Is it merely the playground of space-time? Let's begin with the fundamental concept of gravity itself. Gravity is the force that pulls objects toward one another. It's what keeps the planets in orbit around the sun and what causes an apple to fall from a tree. Sir Isaac Newton famously described gravity as an attractive force between two bodies, a force that diminishes with distance. But as we peel back the layers of this concept, we find that gravity is far more nuanced than Newton's initial observations. In the early 20th century, Albert Einstein revolutionized our understanding of gravity with his general theory of relativity. Instead of viewing gravity as a force, Einstein proposed that it is the result of the curvature of spacetime caused by mass. Imagine placing a heavy ball on a stretched rubber sheet. The ball creates a depression, and smaller balls placed nearby will naturally roll towards the heavier ball, not because of a direct pull, but because of the curved surface. This analogy helps illustrate how massive objects like stars and planets warp the fabric of spacetime, influencing the paths of other objects around them. But what does this mean for our understanding of the universe? If gravity is the result of the curvature of spacetime, then we must consider the implications of this relationship. For instance, if gravity can bend space and time, might it also allow for phenomena that seem counterintuitive? Could it be possible that the very nature of gravity opens the door to concepts like wormholes or even time travel? As we explore these ideas, we encounter a range of theories and perspectives. One notable thinker in this realm is philosopher Nick Bostrom, who posits the simulation argument. Bostrom suggests that if advanced civilizations could create simulated realities, it's statistically likely that we are living in one of those simulations. If this were true, gravity, as we perceive it, might merely be a programmed aspect of our simulated existence. This leads to a tantalizing question. If our reality is a simulation, what role does gravity play within it? Is it simply a game mechanic designed to maintain the structure of our universe? Moreover, we must consider the implications of quantum physics, which introduces a different perspective on reality. Quantum mechanics challenges our classical understanding of physics, presenting a world where particles can exist in multiple states at once, and where observation influences outcomes. This quantum realm appears to contradict our intuitive grasp of gravity and spacetime. How do these two seemingly conflicting realms interact? What if gravity is not just a property of mass, but also a manifestation of quantum mechanics? As we delve deeper, let's examine the evidence that supports or challenges these theories. General relativity has been confirmed through numerous experiments, from the bending of light around massive objects to the detection of gravitational waves. Yet, despite its successes, general relativity does not seamlessly integrate with quantum mechanics. The search for a unified theory that encompasses both remains one of the greatest challenges in physics today. In this complex web of ideas, we encounter paradoxes that leave us questioning our fundamental assumptions. For instance, consider the black hole. As a region of space where gravity is so intense that nothing, not even light, can escape, black holes challenge our understanding of spacetime. What happens to information that falls into a black hole? Does it simply vanish, or is it preserved in some form? This dilemma, known as the black hole information paradox, forces us to confront our understanding of reality itself. So what if gravity, as we know it, is merely a symptom of a deeper reality? What if it's not just the force that governs the movement of celestial bodies, but a fundamental aspect of the universe's structure that connects everything in a grand cosmic game? If we accept that gravity can warp spacetime, we must also entertain the possibility that our understanding of reality is limited. What if the universe operates on principles we have yet to comprehend or discover? Now let's turn our attention to the implications of these theories for our everyday lives. If gravity is just one aspect of a larger cosmic framework, how does this affect our perception of reality? Perhaps it encourages us to adopt a more flexible mindset, one that allows for the acceptance of uncertainty and the unknown. After all, if our understanding of reality is still evolving, then our beliefs and assumptions should be too. As we grapple with these questions, it's essential to actively engage with our thoughts and experiences. What does gravity mean to you? Have you ever experienced a moment that made you question the nature of reality? Perhaps you've had a déjà vu experience, where the lines between past, present, and future seem to blur. Could these moments be glimpses into the deeper layers of reality, where gravity and time intertwine in ways we cannot yet understand? Moreover, we should be open to the possibility that alternative explanations exist. While the simulation argument offers an intriguing perspective, there are traditional explanations grounded in evolutionary biology and neurological processes. Could our perception of gravity be a byproduct of our evolutionary history, a mental construct shaped by our experiences? This raises further questions about the nature of consciousness and our place in the universe. As we consider these various perspectives, we must acknowledge that they do not exist in isolation. The interplay between philosophy, science, and personal experience creates a rich tapestry of understanding. Each thread contributes to our comprehension of complex concepts like gravity and reality. To wrap up our exploration, let's reflect on the core ideas we've encountered today. Gravity is not merely a force, it's a profound aspect of the universe that shapes our existence. Whether viewed through the lens of general relativity, quantum mechanics, or philosophical inquiry, gravity invites us to rethink our understanding of reality itself. But as we ponder these ideas, new questions arise. If reality can be so fluid, what does it mean to truly know something? How do we navigate a world where certainty is elusive? And most importantly, how do we find our place within this grand cosmic game? If you're intrigued by these questions and want to continue exploring the depths of existence, consider subscribing to our channel. Join us on this journey of discovery as we seek to unravel the mysteries of life, consciousness, and the universe. What thoughts or theories resonated with you most from today's discussion? Share your insights and questions in the comments below, and let's engage in this exploration together. Remember, the most profound answers often lie hidden behind the most challenging questions. Keep questioning, keep exploring, and until next time, let's continue to wonder, what if it's all a game?